So this is again to say the dummy variables. If you allow doctors to have a different slope, you have to have many such slopes. Say for example here, if you want to have a gender, we started out with the gender, two parallel lines. And this is what you have to do. This is gender, and you have male and female. This is gender as a main factor and interacting with the age. So that will answer your question whether the age differs by gender. Here there's no time. Whether this can be addressed by adding a interactive term between age and gender. That is a case, what question do we have? Allowing the doctors to have a random intercept. The novel way of doing it, studying, allowing them to have a different intercept and see whether it is necessary or not. A random slope similarly can be done. And by having dummy variables, like for example, I showed you remember this, to see the age and interaction, whether this is necessary or not. So this is the same thing. I remember we drew two lines, that is here, to study whether it is significant or not. To have two different lines, we made this term and see whether it is necessary or not. Now, similarly, if you wanted to see doctors to have different slopes, so then you have to multiply the doctor as a dummy variable for MD doctor and the regression coefficient. So the age, say for example, this is the main factor. This is each doctor into the age and so on and so forth. 11 such factor has to come in the model, which is not a novel way of handling this one. So therefore, what we do is we assess the variability of the slopes. Last time we assessed the variability of the intercept. We allowed them to have a different intercept and checked whether it is necessary or not. And if it is necessary, you retain that model. Now we are doing the same thing by interacting age with the doctor's level. That tells you whether, so you allow them to have a different slope and study the variability of the slopes and see whether it is necessary or not. So besides your random intercept, you allow them to have a random slope and check whether it is necessary or not. So now let us look at the model. Why do I say this is a random intercept and random slope? Anybody would like to answer the question? Constant is meant for intercept. Constant is always meant for intercept. So, but the slope, this is age is a slope. Age variable should have a slope. And this one is meant for slope. This is constant, this is A, this is B. That is, remember, simple regression. This is slope. And this has J in it. So allow the doctors to have different slope. That is what it means. Any questions? So unfortunately, this is different software. In our software, we have something like this. See the difference? The random intercept, we set delta 1 and MD. Here the age and MD. Age given MD. So now the next question is, can I bring one more variable into it? So you can do that. So now this is, if you see in your R code, the covariate was put in the model like this. then it is a random slope model. You can't have a random slope model without random intercept. Okay, so therefore this is a random slope model. Now the standard deviations are here, the variabilities are here. The variability due to intercept is 1.2. Variability due to reage is 0.01. The residual variability is 0.56. So therefore, how do I calculate my ICC in the model after introducing your random slope? What is the concept of ICC? Total variability comes in the denominator. So total variability, total variance. How much is the total variance here? 1.2 plus 0.01, 1.02, then 0.56. So 1.2, 0.01, 0.56. So 7. Am I right? Okay. 1.7 or 1.8. So that is your 1.8, let's say. Then what is the intercept variability? 1.2. So this, how much is the ICC now? 60%, 1.2 versus 1.8. Do you agree with me? Around 60%, which is very high. Okay. By adding a slope model into the from it has gone up from 0.52 to 0.6 something. Is that right? So this is, so the ICC is very high. What we wanted to tell you is that a subject specific model which gives you ICC exactly correctly. Okay. And the next question is what? Yes? Do I need random slope model? Do I need this model, which is a bit complicated? Okay. So therefore, what is the likelihood value here? Do you see likelihood values? Minus 399. So my 399, what is the naive model likelihood? Check your previous screen, previous slide. Let's say random intercept model. Do you have in your previous analysis random intercept model? Same data do you have? Jyoti, you have random intercept model. Can you please check? 404? 404. Okay. So this is 399, almost 400. 400. This is random intercept and random slope model. So random intercept model is 404. Difference is 4 into 2. 2 times the difference in likelihood ratio, 8 degrees of freedom. So, 8 is the value for 2 degrees of freedom more, not 1. Because the random slope is the one which we added. But what happens is the random intercept interacts with the random slope. Therefore, that is the interaction term also comes in between. Therefore, you have 2 degrees of freedom. So for 2 degrees of freedom, with the 8 is significant. So it suggests that though it doesn't seem to be very impressive model, but it is significant. So minimum you need 6 or something, but you got 8 here. So therefore it is necessary that you have to have random slope. Is that clear? Okay. So slightly that ICC also got inflated. It might have some effect. This is about random slope model. Okay. Yeah. That's okay. Now, Can you please do this exercise for the ANC data and tell me whether you need random slope also?